Hello, this is Dave Hansen. I see Sigrid Walker on already.
Yes, good afternoon.
Yeah, good to have you. We'll be getting our speaker on here in the next few minutes. I asked him to dial in a little bit early, like 6:20 here now. So you'll hear us talking, getting ready, and we'll start things up with everybody at 6:30.
Hello, Dave. I know there'll be a big crowd here, so I'm going to mute my iPhone.
All right. Yeah. See folks starting to show up. It looks like you're outdoors there, Douglas. Can you hear me, Douglas?
Oh, I forgot I was on mute.
Okay.
Yeah, we're staying at a hotel while they do work in our house. So
Ah,
we're,
okay.
we're at the house at the moment, but I probably will go to the hotel with Beatrice in a few minutes.
Well, good. Okay. So is my video coming through okay, everybody?
Yes, Dave.
Yes, yes.
Good, good. 'Cause remember last month and the month before, I just had the feather flag. I was trying to get my video, and this time they succeeded. Good. Yeah, Robin, Colin, good to see you there. Sigrid, I already talked to you a little bit.
I apologize for the lack of a haircut in 3 months, kind of.
Well, actually, yeah, my wife and I ordered through Amazon some clippers, and then she gave myself and both our boys haircuts about 2 weeks ago. So yeah, we went quite a long time too, but yeah. So, all right. Yeah, I've been exchanging emails with Jeff, our speaker, and so he should be coming on here anytime. We've got 28 folks registered, and I won't go through a lot of the things until we get more folks on here.
Yeah, I saw a Model Y here in the Clear Lake area, so that was great.
Yeah, that's great that they're starting to get to be around. I knew from the Houston Tesla owners group that there's some around, and I think they were hoping when they did the birthday parade for the guy that somebody would come out with a Y, but nobody did. That was a little bit earlier, so maybe there have been some more deliveries since then.
Yeah, my wife Beatrice is willing to do a test drive in the Model Y, but we have a pandemic.
Well, one thing that I'm going to bring up, I'll just give a little heads up right now. The Evolve Houston group is planning to do a pilot of some Tesla test drives, and it includes the Model Y. I specifically asked that. And so there's Jeff. Hey there, Jeff. Can you hear me?
I can. How are you doing?
Good, good. Okay. So at some point, yeah, you're sounding loud and clear, and your video is good. And
Good.
At some point, I will make you host, and then you'll be able to do a screen share if you like. And we're still getting more folks on, which is good.
Sounds good.
All right. I see Mike Zutek there, and I see some names, Chris Hayden and Emma. I see Bill Swan's video. So I like your background there, Bill, the solar panels. Yeah. Yeah. And of course, Sigrid's got a really cute picture there, her holding the dog. That's really cute. Such a nice picture. Yeah. Yeah, I've got some notes here for some things that Colin and I have been discussing about our setup with Zoom. I'll wait for a few more people to get on before I go through those. And, I see, Jim, you chose to put an EV as you in your picture. That's good, appropriate here.
Right, thank you.
Do you do that anytime you do Zoom meetings, or only when you're doing it with other EV owners?
Well, my family has been putting in various pictures, so this is the first time I've done this.
Ah, okay. Just thought that maybe you wanted to use that for any other types of meetings that you might have joined with other non-EV owners on Zoom or on Google Meet, or
Maybe I should.
yeah, that would be good. I find having a picture like that's always a good starting point of a discussion with non-EV owners. See if they recognize it, if they mention that they recognize what kind of car it is, or something like that. It can be good for starting a conversation.
Very good. I was just advising somebody in my neighborhood about backup systems. There's a whole long conversation going on in my neighborhood bulletin board about backup generators, and I'm ready to let them know that don't go with natural gas because it's smelly and expensive and noisy and requires a lot of maintenance. Go with
Right.
batteries.
Mhm. Yeah, it seems like more and more folks are going that way. Of course, we all know that batteries are getting cheaper. I see Chris Hayden there gave you a thumbs up on that little description.
All right. Thank you, Chris.
I see Emma's photo now in her box.
What is the cost for and size of a typical natural gas generator?
I've not priced it lately. In this conversation online, somebody who's thinking of getting one and wanted other neighbors to chime in. They were looking at, was it 12,000 or 22,000? I dropped a digit here.
My guess would have been at least 10,000. So yeah.
Yeah, I did
15
price it several years ago before the battery systems really came along, and yeah, it was about 10,000.
I have one. I got mine on a small house. It's 2,000 square feet, but it's whole house, and it was about 12.
Oh, there's a good price point. Thank you, Sigrid.
Yeah, that was about when I first moved here 5 years ago.
Good
6
to
years.
know.
Okay.
That's the cost, and what is the size?
Mine is it's full house. I think it's, oh my goodness, I have to go look. I think it's at least 11, if not 12, or whatever the next one is, whatever covers 2,000 square foot house. And I can't remember what the size is right now. Let me look it up and I will put it in the text in the chat if I find it. Okay.
And I assume that's big enough
Great.
to start your air conditioner, right?
Yes, definitely.
Yeah, so
It'll run everything in
one
my
of the
house.
that's one of the problems with the battery inverter systems is that you've got to handle that 80 amp inrush into your compressor. And
Well, it's not
most
saying like the
inverters are not
inrush,
gonna do that.
Right?
the inrush is not so bad. It's trying to have enough kilowatt hours of power to run an air conditioner.
Yeah, I mean, yeah,
Lot
assuming
kilowatt
that you
hours.
have that much, that you can deliver the 40 amps to keep the AC compressor happy, do you have the double of that to get it started?
Exactly. And I mean, I can run my air conditioning just fine,
Mhm.
but I definitely couldn't charge my car.
Well, you just have to be
Not at the
patient.
same time,
There-
not at the
yeah.
same time.
Oh, okay, sure. Yeah.
I can charge the car, but not with the air conditioning. That'd be too much.
Hey, do a little internet search for soft start. That's what Tesla provided me, so I could run the air conditioning off the batteries.
Yeah, exactly.
It ramps up the connection to the
Yeah.
condenser.
Yeah, if your compressor's got that kind of a capability, you could do a soft start. Some of them are all enclosed and you don't really have a choice. But if you've got access to all the windings, yes.
Yeah, most AC units 2 years ago couldn't handle a sure start system.
Yeah.
But
So how about the physical size of your generator? I'm guessing it's about double the size of your AC compressor, kind of about like a 2x4 foot pad.
Exactly. It's about double the size. It's shorter a
Yeah.
little bit, but it's longer. It's wider.
Do you have a
What's
maintenance
the-
agreement with the
yeah,
generator?
that was my question.
I did get it initially. I'm crossing my fingers because when I first got it, that we had a few years later was Harvey, right? And the company did not come out and do what they were supposed to do because it stopped working right in the middle of Harvey. And ever since they've been doing maintenance, they come out 3 times a year and they haven't charged me a dime. So I'm being quiet about that. I think they felt bad because they did apologize profusely because I went a full day with no power. And it's like, this is why I got it, right? But they really did. They've stepped up. They've been really good. And so they haven't charged me anything. So I'm just gonna be real quiet and see when they're gonna finally start charging me.
Because that can be another $1,000 a year.
There you
for
go.
maintenance. Yeah.
Exactly.
Yeah. People think, oh, it's a $12,000 unit, but it's actually, it's a $12,000 unit plus the fuel, plus the maintenance.
Right. If I had to do it again, of course, I wouldn't. I would go with Tesla's batteries now, but that was 6 years ago. And I don't regret it because of how well it's, having it is great.
So did somebody else on the call just say that they have the Tesla set up for your AC?
Yeah, that was me, Jim Thompson.
Well, how long is your, how long are you expected to be able to go without power and operate your AC and lights and the rest of the house?
Well, that's a good question. It's like, how long is the length of string? First of all, if we had a long-term outage, we were out 9 days for Ike. First of all, we turned the pool off. I've got 3 power walls. That's about 40 kilowatt hours of power. That should drive my house anywhere from 1 to 3 days, depending on the load, how hot it is outside, how much AC is running, assuming the pool is off, and assuming there's no solar. With the solar running, I do have rooftop 10 kilowatt hour, 10.72 kilowatts of our PV panels on top. That will keep going during the outage and keep the Tesla Powerwalls charged and power the house. But I haven't given it the acid test with a long-term, say 1 week outage yet. We'll see how it does.
Oh, come on, be brave. Just go out there and flip that big 300 amp breaker and see how long until it goes dark.
Yeah, the app gives you good monitoring. You can watch it charge or discharge until 0, I guess.
Mm-hmm. Interesting. Now, I got a reminder that we ought to do something like that. We had a small pole transformer blow up in the neighborhood here a couple of weeks ago during a rainstorm. And we were actually, we were at strange, funky phasing and 70 to 90 volts where there should be 110, 120 for about 2.5 days. It was fun. The exciting timing of that is that the power outage was a few minutes after the crew left, having just installed my new air conditioner. So I quickly ran over and flipped the switch to off. I was not about to try my brand new machine on that funky power at low voltage just to see what would happen.
Right.
On a smaller scale, I had somebody tell me about using a battery generator on a construction site instead of using gasoline generator, which I had not heard of before. He said it cost about $1,600 and lasted. At the end of the day, they still had 60% power. Every day somebody took it home.
It's also a lot more pleasant on the job site.
Yes. Yeah,
and always starts.
Yeah. I think here in my neighborhood, they take the mufflers off of those things to make them more efficient.
Oh.
Okay.
Okay.
No, they just loosen a couple screws.
Yeah. Somebody's got some screws loose.
Yeah. Okay. So yeah, Jeff, we'll get you speaking here in just a minute, but first it's good to see. So Robin, I see you've got the car behind you now. Very good. Yeah. Little green screen action there. And,
Yeah, that's the second Model S.
Fred and Jason, good to see you as well. And I see the names added here along with Ken, that we have Kevin Douglas, Robert Sanchez, and Chris Hayden. I mentioned you already, and good to see your photo in there, Emma. So yeah, I've got the video running now, and so we don't have all the folks that registered, but that's okay. We'll get started. We've got about 15 folks here now, and so I see in the chat, Emma has put in, someone sent this link during the Battery Storage 101 workshop that Sun hosted. Okay, so about battery costs. All right, folks can look at that. Good. So yeah, some things about our Zoom. So apparently Zoom has heard people complaining about security, and I've tried to avoid using the waiting room or a passcode, but on the Zoom host site, it said today that as of July 19th that they were going to require one or the other. So I'm going to try to avoid the passcode so that people don't have to look for something separate. But if we have to use the waiting room, we have to, I guess. So we'll see how that goes next month. Another change for next month is we're going to change where our hosting within Zoom is at. It'll still be a pro account, so we don't have a 40-minute limit or something like that, as the personal accounts have. But the link will be different than the one used this week. So the one for next month and for the months after, I believe the link will stay the same. But we are going to change with that next month. So let's see. Lots of things happening in the news, of course. Folks have probably been paying attention to all the electric vehicle companies getting a lot of attention in the stock market and in the news. So that's real good. We'll talk about that again after Jeff speaks. But I just wanted to bring up that next week we will have a speaker that we've had before, Vivas Kumar, and he'll be talking about batteries. So that'll be real good. And Jeff, you can dial in as well if you'd like to hear. His title is Electric Vehicle Battery Supply Chain. So it'll be interesting to hear some updates from him since we've heard from him before. And one of the interesting things in the news that I've heard this week, I never knew that there was a definition of gray hydrogen, blue hydrogen, and green hydrogen. So that's kind of interesting. Green hydrogen, most of us can probably figure out that's when the blue is where they sequester the CO2 and gray is worse. So I don't remember the exact definition, but I thought that was interesting that that industry, and since we're here in Houston, this is why I bring it up, is a potential area where our friends that work in the oil and gas industry may turn their attention next, because they've got all these pipelines and other things. And I've been to some meetings over the last several months, more than half a year, including one at the Norwegian consulate. And they, of course, are big into oil and gas over in Norway. So that's the reason their consulate here is so concentrating on that and sponsors meetings and things. And one of the things I heard when I was at one of these talks was that the oil and gas industry kind of sees the writing on the wall, that electric vehicles are coming. So the thing that they mentioned at that meeting that they're really counting on is making more plastics, things like that, as opposed to making more liquid fuels out of what they get out of the ground. So that's why I bring up about hydrogen, is that we, of course, want electric vehicles to proliferate, but we know that those folks in that industry are not just going to lay down and die and say, oh, okay, yeah, EVs are better. We're going to just stop, all the knowledge we've gained over decades of how to drill for oil and gas and put it through pipes and things. They're not going to give up on that. They're going to push for it real hard, of course, to make their industry where they make their livings go a long time. So whereas previous to reading this article, that I used to say, well, hydrogen, I don't know that it's really going to be that useful, but they pointed out in the article that hydrogen is good where you need high temperatures, like for processing steel or concrete, things like that. So besides a transport fuel, hydrogen does have other uses. So if anybody finds anything interesting to read about that, you might pass it around, because you can always go to our website, put things there, there's the forum and such. So I think that's good, because I always look at the big picture. As we see how the EV infrastructure and things develop, I think it's kind of important to also see what's happening with the existing industry, what's powered our vehicles to date. So that's something that's kind of good in the news. But we'll talk more about the news after Jeff's talk. So Jeff, I'll give you a little introduction here. You are the founder of VeloceEngery, correct?
That's correct.
Yeah, good. So I looked a little bit at your site, and it's really interesting. You've got that tree growing right at the beginning on your home webpage there. That's really nice. And the descriptions that you have there. So things happening in the world of the electrical grid will be good. So I see some questions have come up in the chat. So at the end of your prepared talk, we'll go to those and to other live questions, if that's okay with you, Jeff.
Glad to.
Okay. So let's see let's see. Where is my post sharing? Oh, I should mention to everyone seeing it up here in the corner that we are recording this meeting, and our intent is to make it available either directly on our website, or we may have a link on our website to a YouTube location, because that's a convenient place for videos, especially one like this that might go over 2 hours. Long one will go to. So let's see here. If I got the capability of. So Jeff, do you have a share screen at the bottom?
Yeah, I think what happens is I know you disabled it, so you've got to let me do it.
Okay, so yeah, it says multiple participants can share simultaneously. Does that give you a?
Yeah, now I can.
Good.
You should be seeing my screen.
Yep, looks good.
Okay. So first, thanks for having me over here. It's great to share our ideas. We have a lot of activity, obviously, out in California, up in the Northeast. Nice to see, Houston becoming more engaged in the, new infrastructure ideas. And what we're looking at, EV charging. You folks, some of you have electric cars. Probably you charge them at home, and you charge them off a little wall charger, either a 110 outlet or a 240 volt outlet at like 7.5 kilowatts into the car. And that's like, maybe 20 miles an hour you can get out of a charger like that. I used to be president of Tritium, which is a global manufacturer of EV chargers, high-speed DC EV chargers. In the US, ChargePoint sold them for a long time as being their 50 kilowatt chargers with all the Tritium chargers. But Tritium makes chargers up to 350 kilowatts. And a 350 kilowatt charger, if there was a car that could take that much power in, gives you about 200 miles in 10 minutes. So it's almost a gas fill up in 10 minutes. The popular charger that we sold from Tritium in the US was the 50 kilowatt charger. And the way I look at a 50 kilowatt charger is in a 10-minute stop, you can get about 30 miles. And 30 miles is what people drive in a day, more or less. So you stop for your coffee in the morning, plug in, come out of the coffee shop, and you got your mileage for the day. You never have to really go anyplace to charge. If we had chargers all over the place. And you can see in the background there, those are the Ionity chargers. That's a big trans-European network that was set up by a group. It was the 6 major automakers out of Germany. VW, Audi, Porsche, Ford, BMW, Kia, and Honda have joined in now. And they're putting 6 of these 350 kilowatt chargers. It was 350 kilowatts because Porsche was supposed to charge at 350 when they came out. And they were all ready to go at 350. And on my old work computer, I had a secret video of them charging at about 340, but we couldn't show the video to anybody. And then they came out and they can only charge at like 230, which was a huge disappointment. The whole network was built for they could charge fast, but they'll get there. Charging rates will go up there. But what this does is when you have chargers that are 50 kilowatts or 150 kilowatts or 350 kilowatts, you pretty quickly get into really big power loads. If you look at the picture that's behind the right side of the screen there, that's part of a station. It's the largest charging station in America. It's on the top floor of the Pasadena Municipal Parking Garage. It's got 24 Tritium 50 kilowatt chargers and 20 Tesla chargers. So 24 50s is 1.2 megawatts. The Teslas was another megawatt and a half or 2 megawatts. So call it 3 or 4 megawatts of charging on top of a parking garage. That's the largest charging station in America. But when we have ubiquitous EVs, we need a lot of those charging stations. So all of a sudden, charging stations becomes the biggest, ugliest, hairiest, difficult load you can put on the utility grid out in a normal commercial area. This is an industrial, this is a normal commercial area. And the grid's just not built for it. And so what happens is, well, I'll get into that next slide. So anyway, big problem. And then a lot of people say, well, we don't need to worry about that because people will just charge at home. And I said, well, that works for people who own a home, who are planning on staying in a home. I used to sell solar energy. Nobody wants to do anything to the home because everybody's going to move in 3 years. Maybe not now anymore, but the excuse used to be, I can't do solar in my home. I'm going to move in 3 years. Where? Why? I don't know. I'm just going to move. So people don't want to put chargers in the garage unless they have to. So it becomes a barrier. It's great to have one in your garage, but if you didn't have to, if chargers were out in every street corner, why put one in your garage if they were fast? So, and then of course, there's the half the population that doesn't own a house and doesn't go to a workplace that could have charging. And so we need, even if everybody who could charge at home, we still need an awful lot of chargers out. And then even people like me who have a charger at home, if I want to drive further than one battery charge, then I need to have a charger someplace outside my home. So one way or another, we need a lot of chargers outside the home. Where we put those chargers, how we put them in is a big debate. And it's being driven somewhat by, well, what can the grid do? So we're trying to take that obstacle away. But I love the idea of putting them in every strip mall so that when you run in to get your bag of donuts, you charge your car. When you run in to get your coffee, when you run in to pick up 3 things for dinner tonight, when you run into the barbershop, when you run into any errand you're doing, you charge your car. So you actually never go to charge your car. So people say, well, it takes too long to charge your car. Well, it only takes too long to charge your car if you have to stand there and hold the nozzle like you do in a gas pump. With chargers, of course, you got to pay and plug in. There's now a new protocol, which is going to be rolled out over the next few years, called plug and charge, where you literally walk over to the charger, you take it off the handle, you plug it into your car, the car knows who you are, the charger reads who you are, it all goes through, you get billed, but you plug it in and walk away, plug and charge. So it takes you 7 seconds to hook your car up and get your charge. So you can plug in for 5 minutes, you can plug in for 2 minutes, you can plug in for 20 minutes. So you never have to go someplace to charge if chargers are everywhere. People say, well, let's put them at the convenience stores. Problem with convenience stores is there's very little power at a convenience store. It's a very light load. Most convenience stores can't even support one 50 kilowatt charger. And of course, you don't want to have a level 2 charger there because convenience stores they want traffic in and out, in and out. They don't want people sitting there for 2 hours or even an hour to charge the car. It's too long. And of course, if we want to take a trip, we need them on the highway. So we'll need chargers on the highway too, obviously. So the stepping back now a little bit, Veloce is about, Veloce means fast in Italian. And that's what we are. And we're trying to make the transitions to the electrification of everything faster. And having been in clean tech businesses most of my career, the way to make something be adopted faster is to let people make money on it. So the free market works, or the so-called free market works, if we can make things profitable. So we're working to lower the cost of connecting into the grid so that we can have things be connected easier and faster. So the shift to electrification since the pandemic happened has been staggering. The number of climate pledges that are coming out, people can see clean air now. We could talk about clean air all we want to. We could talk about the lack of pollution from an EV, but nobody understood it. Now people viscerally see it. I've got buddies who live 20 miles from the Pacific Ocean. They'd never seen the ocean from their house. Now they can see the ocean from their house. So that kind of visible change, people seeing mountains, people seeing across the city, people now they now get it. And politicians are people sometimes too, and they see the same thing, so they get it. So the transition's happening faster now. We were already beginning to accelerate, and now the steamroller has been accelerated. So we're looking to attack EV charging, but also attack the entire grid edge. Our stealth mandate internally is to make EV charging cheaper, easier, and more profitable for the owners, but to then transform the entire grid edge, because we don't have enough money or time to rebuild the entire grid. We need to instead build onto the edge in a different manner, such that we can highly leverage the existing asset. The grid's used at about 50% utilization now in terms of average power flows. Peak is up here, minimum is down here, and average is about half the capacity. So if through different design on the grid edge, different loads and such, we can raise the average amount of power used up to 60%, 70%, 80% without rebuilding the grid, we're using an existing asset better. Shouldn't we do that? That just makes sense, right? We want to sweat the asset, use that asset better. So that's what we're about. Is we're about making this transformation. leveraging the infrastructure to achieve the goals, creating the networks, redefining the distribution, leveraging our infrastructure to transform the grid. So back down to transportation, we've got a challenge of electrifying transportation and electrifying everything. We need chargers one way or another. Deploying chargers is very hard. In California, it can take 18 months to get the connection to the grid. 18 months because of the power levels needed and the fact that the power levels are needed in places that don't have extra power levels. 18 months and hundreds of thousands of dollars, which make it hard to make a profit on a charging station. So we're coming in with our grid edge energy network solution, which is applying energy storage in different ways in charging stations and other parts of the grid for other applications to use the grid better. So we need to do less upgrades of the grid. If we need to do less upgrades, we can go faster. It costs less money. We can get charging into the grid edge. And then, oh, by the way, we'll end up with batteries to the grid edge. Batteries to the grid edge are a good idea because then all of a sudden you have resilience. We can connect buildings to these batteries, get resilience in buildings. And then not a bad idea to have some batteries at the EV charging station for when the hurricane's coming, your car's out of juice and you need to leave and the power grid's down. Be nice to have a little bit of stored power, either for us to leave or for the emergency vehicles that are electric to be able to recharge when the power's out. So having some energy storage at these charging stations has a whole lot of benefits, but nobody wants to pay for them. So we're finding a different way to make them cost effective. So we have the batteries there. This is what our station looks like. The box in the middle here, we call the V port. That is a extremely flexible, extremely modular battery system with a lot of intelligence inside of it to make it operate in the electric vehicle charging station market. And then this architectural piece up here is not just a banner or a sign or a piece of art. This actually is how we transfer power from unit to unit. And this is part of our novel design. If you've ever seen construction, you know, the first thing you do in construction is dig a big trench, right? And then you put a bunch of electrical conduit in that trench. And then you pour gravel over it, and then you pour concrete over it. And you've got this big trench open for 2 weeks. And there's a lot of permitting involved in that. And what I've done a lot of construction, and I found out that whenever you dig a hole, you find things you didn't know about. No matter what the survey, you know, you've done your survey, you've done your research, but we call it the magic backhoe. The magic backhoe comes on site, puts a scoop in the ground and finds things. So if we don't dig, we don't find things. So this system allows us to dig only enough to put concrete pads in under the equipment. And that will streamline construction time, remove a lot of the risk from it, and provide some efficiency through the system as well. The system also, go to the next page here. I'll show that next. This system also makes it very much easier to expand. I'll show you that on the next page. But here's the battery energy storage system. We have intelligence inside. The Fast Connect system allows us to install this quickly in a very flexible way. Another point about being above grade is over half the cost of an EV charging station is buried in concrete under the ground. If something doesn't work out and you want to move that charging station, you can move the chargers pretty easy, but you can't move all that stuff that's buried underground. Our stuff, we can move. We can take it down. It's not free, but we can take it down and move it. It's not hard to do that. So this whole thing is what we call the fast grid system, and it will work with the level 2 chargers you see over here, hang on the leg. It'll work with any OCPP compatible charging. OCPP is the Open Charge Protocol program. It's the language that the companies who control the chargers, say an EVgo or Greenlots, that's the language they use to speak to the charger and command it. So you go up, you pay with your credit card, it transmits that data to the charger system operator. they say, okay, turn the charger on. That command comes back in OCPP. That's the language. So we need to talk to these chargers too, and our software is all designed to work with OCPP compatible chargers of any scale. So we can do, you know, the level 2, we can do 50 kilowatts, we can do larger. So you can see in this rendering, the Fast Connect ends here. To extend the system, we don't need to dig up anything or disturb anything. We literally take the end cap on, bolt on another piece and the cabling, and just keep on running it out. So it's very easy to expand. And yeah, if there's one thing that's true about any charging station you build today, it's going to expand in the future. Because if you need 2 chargers someplace today at 2% EV penetration, we're going to need 4, 6, or 8 chargers in the same place later on. So most charging stations are going to expand. And to do that same thing today with construction, you need to put all that future conduit in the ground on day one. You've got to invest all the extra money in a bigger trench, more conduit, more labor today when you might not need it for 5 years. Or you've got to dig the site back up again. Take your choice. So if we want to look at EV charging, one of the other innovations we're bringing in, which is very important, is, as I said, the grid doesn't have the capability to support these big charging stations. Grid doesn't have the capability to support small charging stations in a lot of places. There's one installation out in LA at the LA County Supervisor's Office, guy I know, and they put in 29 level 2 chargers. So do the math, 30 times 7.5. You know, 250 kilowatts of charging, okay? The bill from Southern California Edison, in California, Southern California Edison basically bills themselves to do this. They pay for the work to get it out to the chargers. The bill for 29 level 2 chargers was $400,000. We can't afford to build enough infrastructure to charge the vehicles that we all want to have if we got to pay $400,000 for 29 level 2 chargers. It doesn't work. I'm not a mathematician, but I don't need to be. That's pretty simple math. It doesn't work. So what we do is, say we had a 600 kilowatt charging station. I'm just pulling out a number out of the air. 600 kilowatt charging station. It was, you know, so either 12 50 kilowatt chargers, or maybe a couple 150 kilowatt chargers and some smaller ones, any combination that adds up to 600 kilowatts. We do the analysis of what the use pattern is and such, but generically, we would connect that station to a 300 kilowatt grid connection. And it turns out that connecting to a half-size grid connection doesn't save you half the money of the connection. It saves you usually more like 75% or 90% or 100% of the grid connection. Again, I haven't done much work in Houston yet. I hope to change that, but in LA, if you can connect below 300 kilowatts, you submit a piece of paper. 21 days later, they tell you if it's okay or not, and you're done. If you submit for 301 kilowatts, it's an 18-month process and 6 figures. So by you know, that's LA, but other places have similar issues. So by crushing that connection size down, we can speed the installation up, put it in this year rather than next year, save a lot of money, save more than enough money to pay for the battery system. And then we save more money by other things we do. So we actually install chargers with batteries for less money than installing chargers without batteries. And then we get all the different capabilities that the batteries bring to the grid edge as well. You know, we can do the ancillary, all the battery services, ancillary services. We can get the resilience. We can do the emergency charging. We have lower demand costs because we've got a lower connection size. So we roll a whole lot of benefits here together because we're looking at the charging station as a whole rather than just throwing a battery under an existing design. And I just want to throw this out there. This is not EVs. This is the whole grid. We can do a similar thing because our system is designed. Let me go back up here for a second. Key component is this box isn't accident. It is purposely sized that size. When you install EV chargers, you end up with about a 3-foot aisle space where the EV chargers are. This is showing a tritium charger. Most chargers are much deeper than that. The charger is about 2 foot deep, and they need back behind them for space behind them for airflow and maintenance. So you end up with a 3 foot deep aisle. So our V-port battery box is 3 foot wide. It's made to fit in that aisle. So we're not taking up extra space. And oftentimes you think, well, how hard can it be to put a container of batteries down someplace in a big open parking lot? It's really hard. People either don't want to look at the container, they don't have extra parking spaces, the municipality doesn't allow them to lose parking spaces. And so it's very common to not be able to put a container of batteries someplace. Or you have to put it way off in the corner over there someplace, and now you've got to add more trenching to go from way off in the corner over there back to the charging station again. So you're adding money. So we're designed to go right in the charging station. We can take that same philosophy, and we're still working on the renderings. We're a young company. I'll tell you how old we are in a minute, but you can take the same philosophy, and we put these V-port modules to do grid support for any kind of problem. Rather than doing grid, they're doing a grid upgrade in my neighborhood here. They're putting new, I think it's 66 kV across the neighborhood, dropping down into the 11 kV to repower it because, you know, it's a 1965 subdivision, we run out of power. So they're doing probably a, you know, $1.5 million, $2 million upgrade that's taken them a year to do. And then by the time they get done with that, they'll have an inflexibly built system for the future. We can take the same problem and put batteries all around the subdivision. We don't have to grab some big piece of land. We don't need to go to the substation. We can just put batteries all over this place. And now we can create using some AI, we can create a network that automatically reconfigures itself to meet whatever loads are happening. So if we've got a whole bunch of people who are putting in, say, home chargers and solar systems, and the grid's kind of doing this over the day, and on average it works fine, but at any given moment it doesn't work fine. Well, if you put batteries in, you can make the average come back and work better. The batteries can act as a sink and a source, depending on what's going on in the neighborhood. And over time, they can predict that, and we can figure it out, and we can make it all operate very well without doing a grid upgrade. And then when things change in the future again, we can either finally do a grid upgrade 10 years later, which is deferred capital, is capital not spent, or we can put in some more batteries or rearrange the batteries. So it creates a lot of flexible system, and we believe we're still early in this, but we believe that this option will be significantly less expensive for the utilities and more flexible. So, yeah, I wanted to run through the slides pretty fast because you can see the size of the unit there. Because I wanted to get to questions and talk more. I can talk too long sometimes, but you know, just to tell you where we're at, I'd been incubating this idea. I was at Shell back in 2018 for a bit. I left there because it's not a good home for an entrepreneur. And I was incubating this idea a bit and got called in to be president of the Americas for Tritium for a year. Well, I got called in to be president of Americas for Tritium and came in, and it was we'll say it was an interesting place to be, and had to do a turnaround. And so I did a turnaround in 2019, met some great folks, and but declared victory in December and left, having turned it around, but not wanting to pursue it further. So came back out in December, restarted working on this. We actually officially incorporated on May 4th of this year. We started our design for the prototype in mid-March. We finished design of the prototype mid-May, and we created marketing materials, in which you see some of the output there, and launched our seed funding round June 1. So right now we're raising seed money, and if we can get the seed money raised in July, we'll be able to get this product through UL listing by end of Q3, and have a product available to sell to the world in Q4. So love to take any questions. Should I go to the chat first and look there?
Yeah, why don't we start with the chat first, Jeff? Can you see that?
I think I need to stop sharing to see the chat.
Okay, can do that.
Oh no, here it is. There, I can see it. Okay. Who and what sector is VeloceEngery's biggest clients? So we have exactly 0 clients today because we're a brand new startup. Who are we selling to? We are selling to the charge point operators. So that's the Greenlots, EV Connects, EV Goes of the world, who then their business model, EV Go buys and owns their own systems long-term, as does Electrify America. The other ones resell equipment to other people who own long-term. So we'll be selling to those entities because if we can make their systems less expensive, total cost of ownership lower, then that benefits them and their customers. Second market we'll be going into is fleets. There's a lot of demand right now for pilots for trucks, medium duty, last mile trucking, and many depots are short on power because they had to power lights and conveyor belts, and they're trying to charge the trucks at the same time the lights and conveyor belts are on. So it'd be 18 months for them to get to a pilot if they don't do something, because it's 18 months to get the power. So we can come in and help them do a pilot much faster. So fleets will be a very important part. And then we are already talking to utilities about utility owned or utility sponsored charging as well. Those are three main sectors at this point in time. Did that answer that question?
Yeah, I think that was good.
Okay. When do I think the cost of an EV will be equal to the cost of an ICE? So today, actually, the answer is today. I just saw this yesterday, and Dory, who says hello, said, make sure you tell the group about it tonight. GM and a few other manufacturers, because the car sales are down so far right now due to coronavirus, are offering drop dead deals on EVs. You can buy a Bolt $15,000 off for, like, I think the price I saw was $28,000. So in answer to your question, yesterday. When do I think on a non-sale mode they'll be? I usually think Tony Seba is pretty aggressive, and I like that. I like what he says. I think he's being a little conservative here. Bloomberg New Energy Finance is saying, depending on how you count it, 2023, 2024, 2025. Of course, when Bloomberg estimates the cost of an electric car, they throw in the cost of a home charger into the price, which is wrong, but at least they disclose it. So I think it's going to be first cost basis, as soon as VW offers a car here, which is, I think, slated for 2022. And I actually think that as soon as that happens, we will be in a supply shortage for the vehicles for the 5 years after that. So capacity of the battery, that's IP at this point. It'll suffice to say, we don't put an enormous battery in there. It is between 2 and 3 digits of kilowatt hours per V-port, because each V-port is very flexible, and then we can also add V-ports in. So with the Fast Connect, it's made to add a V-port in anywhere. So different use cases require different amounts of storage, different utilization rates. All that being said, for public charging, if you don't actually have to move power from the day to the night or vice versa. You can move it during the day back and forth. So it results in a reasonably small battery to get reasonably high utilization rates. Yeah, I mean, so load shifting, load leveling, all that stuff. You usually, whenever you're a battery, you usually have about 8 different ways you can use the battery, and the trick is trying to find out the 2 or hopefully 3 that you can mush together and not have them conflict with each other. Because oftentimes, if you want to do this with it, it means you can't do that with it, or you do this with it for so long, and then you're out of battery and you can't do that with it. So that's where the intelligence comes in to figure out how should you best use the battery today. Now, it's a little easier in our case because our job number 1 is to make sure we're available to charge cars. And then after we take care of that, then we can do job number 2 or job number 3. So the calculus is a little easier in our case. So solar panels. So, you know, I am a big solar guy. I led the solar industry for quite a while. And so I love solar. One of the problems with solar is it complicates a site quite a bit. So we've designed our system to not have solar on it or be integrated to it, but we've also designed our system so it's very easy to connect solar into it electrically. So on sites where solar makes sense, on sites where solar wants to be added, or on sites where solar already exists and wants to be differently connected, we can add that in and connect it, but it would be on its own racking and support structures, not an integrated structure. And not only can we add in solar, but we also, longer term, Dave, you were talking about the hydrogen economy earlier on, and we believe that longer term in bigger truck depots and such, and maybe along the highway, I think that they're actually, I'm not a big fan of hydrogen vehicles, except on some long haul. I think it could work out. But what I am a fan of is putting hydrogen at the grid edge in fuel cells to help negate grid upgrades. So if you need hydrogen on a grid edge to power a hydrogen vehicle, let's throw a fuel cell there as well. Now we've got hydrogen storage doing two purposes, vehicle and fuel cell. And we got fuel cell there, which just crank along at a steady rate, easy to connect into our system. And now you've got a whole energy hub that's created there.
So going back to the solar question, so I noticed your, I don't remember what you called it, the archway over the top with the cabling?
The fast connect.
Yeah, that. It seems like it'd be a perfect place to connect up a shade structure, because I know having taken road trips in Texas in the summer, all the chargers are out in the sun and it's quite warm standing there, you know, fiddling with the app, getting the charger started.
Yeah, the problem is that when you put a shade structure on there, now your structure has to be much beefier, because we get winds down here sometimes.
Occasionally.
and we'd like them to not have the shade structure blow off, and it means that the leg has to be much stronger to resist those wind forces. And now we probably got to take that leg and put a 5-foot foundation underneath it going down. And we're trying to not dig. So any kind of a shade structure, it helps us with one objective, but it screws up another objective, which is to get these units out there quickly and as inexpensively as possible. Solar kind of pays for itself, but as soon as you put it on the charging station, it makes the charging station not able to pay for itself.
Actually, thinking about it, you know, once plug-in charge is a thing, I don't need to stand there and
Yeah,
fiddle with
there
the
you
app
go.
for 5 minutes.
Yeah. I mean, I'll tell you, I feel your pain. I had my head of support at Tritium went out to do some investigation of somebody else's charger at a new site, and he took one of the EVs we had for testing. He went out to this brand new Electrify America site, and he plugged in it was BMW i3 to charge. Brand new site, wouldn't charge. Plugged in, there were 8 chargers. Plugged in another one, wouldn't charge. He spent 2 hours at that site to get 15 minutes of charge. So the communications between a car and a charger are actually incredibly complex. It's one of the most complex things that happens in the whole charger control is communicating between the car and the charger. And it's partially because the standard that the communications is done on is a fairly weak standard. So there's a lot of variance, but that it's a huge pain point. Half the failures that we have in charging are because the car isn't communicating to the charger, or the charger is not communicating to the car right, and that causes user frustration. But the goal is to make that better. The goal is that in another 2 or 3 years, because the masses we'll all put up with this stuff, but the masses won't.
I've also heard that there was an article that some older cars like the Chevy Spark can actually kill charging stations. And so they'll go from stall to stall to stall, killing each one in succession because their car throws errors in the connection sequence.
I haven't heard that. I never heard that. I never heard of any car that could kill our charger in that way.
Not
They were,
kill per se, but a you know, like cause a fault that needed the station to be, or the stall to be rebooted.
yeah, I mean, and again, some other manufacturers, which I'm not familiar with, may have had more problems. We could do a lot of the rebooting and a lot of the maintenance remotely. So if that was to happen to a Tritium charger, it would come up as a support ticket, and which is, you know, they'd flip a software switch and away it goes. There are, again, speaking Tritium, they had a lot of experience, and they would do a lot of testing on vehicles because they had enough experience in vehicles that their charger pretty much always worked on a vehicle. And if the vehicle didn't communicate to the charger, the vehicle had a code problem. And trying to convince, you know, these august 100-year-old German manufacturers that their software was screwed up, not ours, was interesting.
Yeah, I bet.
we succeeded, we won, but it was not an easy conversation.
Uh-huh. Okay, did that cover all the questions in the chat?
I did, yeah.
Okay, so folks live online, we've got 17 folks here for asking Jeff live questions. I was kind of wondering, is part of what your company doing approaching condo complex owners and things like that to see if they want to use your system?
So we're trying not to have a huge sales staff. So you know, we're very much working with the folks. We will be working with the folks who approached condo owners and such. But you know, I'm much more of a fan of putting chargers in the strip mall next to the condo rather than at the condo, because again, I'm a fan of higher speed charging. We can do level 2 charging, it's fine, but I'm a fan of higher speed charging because the more people who have access to the charger, the higher the utilization is, the easier it is to pay back the charger. Whereas if you start to put these, you know, in the condo association, in this area, in that area, you're automatically limiting traffic.
Yeah, you're talking slower speed where somebody parks, plugs in, leaves it there overnight because they're going to bed that night. Whereas, as you say, at a strip center, it's for somebody who's coming in for just a short amount of time.
Yeah.
Okay. And we've seen with Tesla having created the urban supercharger that it's a model to address people who don't have a place at home to charge. So as you say, you go pick up your donuts or whatever, and you get a bit of charge while you're there at a fast charger, and you've gotten a significant amount. Yeah, going to the donut store and plugging it into an L1 isn't really going to do anything for you during the time you're there. But you're using that time to pick up donuts with fast charge very efficiently, using your time very efficiently.
Yeah, and I'll tell you what, if one donut shop has a fast charger in front of it and one donut shop doesn't, guess where I'm going?
Right. That's the kind of thing that I thought also would be true, yeah. Mm-hmm. Good, so more questions from folks?
Jeff, this is Kevin Douglas. Did I understand that you're saying that about half the demand for charging is expected to be folks that don't live in residences or work at places where charging can occur? Is that an accurate number?
Well,
50%?
There's a lot of debate about this. I mean, the numbers, if you go research stuff, about 65% of people supposedly live in single family homes in the US. Of course, a lot of those, you know, a bunch of those are renters and such, and then you've got a bunch of those that you know, electrical panels would need to be upgraded to put in a charger, and so you got a lot that can't do a charger. But let's say, rather than 65%, 50% being generous, that people live in houses they could charge from. So that leaves half the country without access to a charger. Now let's be super generous, since of those half of them can charge at a workplace, and which is being super generous, because you know, half the people who live in apartments don't necessarily live at workplaces that could have charging. And there's a lot of folks who, you know, don't go to a workplace every day. Construction workers, just for one, right? So that leaves 25% of the populace with no place to charge other than their apartment building. I'm an apartment owner, say, and 2 people in my apartment block have EVs. I should go put in chargers for them, right? Sure, but then their leases come up and they move away. And now I got 2 chargers I paid for that nobody's using at all. So and if I got a grant to pay for them, that grant just went to buy 2 chargers that nobody's using at all. So it's either way, it's wasted money, right? So I look at it as kind of the far bookend, the fewest number of people who need public charging. And they need fast public charging because they don't have a place to sit for 2 or 3 hours. The smallest number is 25%. I actually think it's much more like 50% or higher, but the smallest number is 25%. 25% of America is a pretty big number.
One of the things that this is Kevin Douglas again. I'm a firm believer in there's no one bullet that's going to solve it all, and so everything has to be done, and the way everything gets done is that each individual piece gets done. So I applaud you guys for working on this solution, because we certainly need an explosion of electric vehicle charging infrastructure, and this is going to be a large segment of it. So this is great. Thank you so much for presenting.
You're welcome. Thanks for the kudos. And I try very hard not to use the word explosion with chargers, but rapid accelerated growth. Yeah. Now, I'm a big fan of all of the above in terms of solutions. I was in the solar industry for a long time. I did residential and commercial, pretty much a little bit of utility. But I always said, look, we need residential solar, we need commercial solar, we need utility scale solar. We need every piece of solar we can get. Same thing with chargers. Same thing.
And Kevin didn't mention it, but he drives his Bolt to San Antonio all the time, so that's a good long stretch. And he drives another car to Knoxville, Tennessee, so of course he's charging along the way to make long distance travel. Yeah.
Yep.
Good. Okay, so more questions from folks.
This is Rob. Jeff, is there a minimum threshold size and number of stalls that makes sense with your system? 4, 8, 16?
I mean, well, I was going to say, but below 2 or 3, it doesn't make sense.
Well, right.
Anything above 2 or 3 starts can work.
Okay.
And again, it really depends. If grid connection is cheap and easy, and you don't value resilience, don't use our system. It doesn't work. You know, happened in Oklahoma. You can get a megawatt grid connection for free in about 2 weeks.
Wow.
Their grid is very strong and not well used, whatever. And so, you know, Oklahoma is not our marketplace today. It will be tomorrow when they build out stations and want to add on to them, because then they can add on without bringing a new grid in. But yeah, no market in Oklahoma today, which is okay by me, I guess.
Well, and just info for you, Jeff, we had a previous call between our chapter and a chapter in Oklahoma of EV owners. And it was interesting. They were talking about a common stretch between 2 cities that a lot of their EVs go back and forth on.
Well, Oklahoma is slated to be the first state with a statewide high-speed charging network, non-Tesla statewide charging network.
Okay.
That's company Francis Solar, which is now called Francis Power, maybe, was politically connected, got some tax credits passed, had the ability to use some tax credits, and worked their sweet butts off and deployed. They planned to deploy, I think it was 250 kilowatt chargers on a 50-mile grid across the entire state.
Wow. Okay. And there's a lot of that state that's not densely populated. I mean, there's the big urban areas, but
yeah,
a lot of rural too.
Yeah. No, it was quite an impressive undertaking. Great company.
Yeah. So thinking of charging networks, what do you think of Electrify America? You know, how it got started and everything.
So I love and hate. It's interesting. The 2 largest charging networks that own their chargers, Electrify America and EVgo, were both founded on money from pollution funds. EVgo was founded by EVgo was founded by NRG, based on funded by $100 million fine in California.
Oh,
Yeah, that was however many years ago. And then of course EA is funded by the Dieselgate money.
Right.
So it's great, gets a lot of charges out there. It's also horrible because other companies have a real hard time competing against free money. You know, EVgo now is you know, they've now obviously gone through the $100 million and now they got to try and make a business out of it. But they do have all these assets at least that kind of bought and paid for that they can, you know, get revenue out of. EA is it's hard to compete against free money, right? So I want to go start up an EV charging owner system, and I got to actually pay for my chargers. So it's really hurt competition, and you have oddities like Francis Solar that was able to find a way around it, you know, in Oklahoma and maybe some other states, but I think it's been in that way bad. So I'm actually looking forward to when EA runs out of money.
okay. So they'll build a certain amount of network, and then you think they'll stop because of the way they got started with that money?
No, I think they'll keep on going because I originally they were supposed to be separate, but then VW maintained control of them. So it will be the VW network, and they'll continue to build, but they'll have, you know, a $2 billion base of asset in the bank account that they can leverage to build more. So it will give them an unfair head start forever in the business.
Yeah, I've always kind of thought that EA was going to keep that tight coordination with VW. I mean, we've all read how VW has come out with the ID3 in Europe, and they're going to come out with the ID4, and they've got a number of models. And of course, they're doing it a lot for the home European market because of that drop from something like 120 to 95 grams of CO2 per kilometer. So they know that they're going to be selling a lot of EVs there, and they know that they're going to need a network here if they expect to sell.
I don't know if
here.
they know they're going to be selling them or not, but it's cheaper for them to invest the billions in converting to EVs than it is to pay the annual fines.
Sure. Mm-hmm.
They have to, if they didn't convert, they have to pay more. So it was,
Right.
I mean, Europe did a great job of making it a really easy business decision.
Yeah. Well, and I think the German government helps the car makers there. I just read that the gas stations, all gas stations in Germany are going to
Yes.
require chargers.
Yes. Yeah. Yeah.
So,
Yeah.
I mean, that'll really ease the public's mind, I think, when purchasing a vehicle, knowing that every gas station, even if they may be slow chargers, I don't know what the law actually says, but
I
still,
think it's not slow charge. It's faster charge. Yeah.
Oh, it even is. Okay.
Yeah.
I wasn't sure about that, but it's still,
Yeah,
folks
we're actually
are familiar.
we're talking to one of the oil companies who's involved in that because the stations don't support the power. So we're talking to one of them about working on that potentially.
Right, that's what I would think, is if they're fast, then that means there's going to have to be a lot of setup done to get the power to the gas stations, because traditionally they haven't been big electrical draws, just small. And but I think it's really good in my mind when I read that. I think it's going to reassure people thinking about buying an EV in Europe, in Germany, because the fact that most everyone's familiar with where the gas stations are, where they live, where they travel to often, and so forth. And so they know that whenever the effective date of that law is, that from that point on, that they won't have any problem, you know, getting around traveling, not having to pay attention to their fuel gauge ahead of time. I've had conversations with folks because a lot of people, they drive until the light comes on their gasoline car. And I tell folks that, you know, for the local driving, I don't care. I don't even look, but for long distance driving, it takes more planning than it does with a gasoline car, because you're not able to do a fast charge as many places as you can fill a gas car up with gas when you're traveling on roads you're not familiar with across multiple states. So I think that
Europe has the Ionity network also, which is the picture I showed you is 6 fast chargers per station, and they're building 400 stations across Europe. It's not. I think it's about 2/3 or 3/4 built out now, but you can now travel across Europe on the highways and have fast chargers. The fastest chargers on the planet, basically, available.
Okay.
But that's the kind of thing, I mean, the automakers did that because, you know, the fines are coming. They have to build EVs. They have to take away the anxiety with people to buy EVs. So they built a charging network. And, you know, the inside baseball story is that charging network was supposed to be built in the US as well. And 3 days before the announcement of the overall Ionity network, when it was going to be announced in North America and Europe, one of the major car companies whose name has 2 initials in it and who had a big fine, pulled out of the Americas part and said, we're building our own network. We'll build the Europe one with you, but we're building our own network, so don't announce it. And so they killed a cross automaker Ionity style network in the US because they wanted to build their own.
Wow. Yeah.
So I like a lot of things about that company now compared to, say, 4 years ago, but there's some things I still don't like.
Yeah. Yeah. Yeah, that's understandable. Okay. More questions for folks?
I see one here about Chamber of Commerce, talk to members.
Oh, okay.
It's the sales staff right now is me for a few hours a week. My chief sales officer is coming on board in the next couple of weeks full time finally, and then we'll have me a little bit and him full time. So we to say we're lightly staffed is an exaggeration. So we're looking for a few big customers who might do pilots at this point in time. We really have to focus our efforts pretty strongly. I am talking to Evolve Houston. I know Chris George, of course. And,
okay.
There could be some opportunities there.
Good. Yeah, one of the things I was going to mention, you're welcome, of course, to stay on through the very end of our meeting here, but during the otherwise discussion outside of questions to you, I was going to mention how Evolve Houston is really speeding up its involvement here in Houston.
Yeah, they're I don't think it's any secret. They're trying to copy part of LA's playbook, which is great, and try and really accelerate stuff. And we do want to work with them, and I think there's a good opportunity to work with them because, again, resilience of charging is certainly important to have some resilient stations around, as well as the fact that look, it's an urban grid from CenterPoint. A lot of places haven't been invested in a long time, and to try and bring a lot of power to metro stations or to truck depots or even to community areas for public charging, CenterPoint's going to take years to do much of anything. So we got to accelerate it.
Yeah. Okay, well, thanks a lot, Jeff. Appreciate it.
Well, my pleasure. And I'm going to drop off because I got to go back to work. It's a startup.
Yeah. Well, that's the job of an entrepreneur. Yeah.
The workday does not end here. Yeah.
Work 24 hours.
But I really appreciate having me on, and I appreciate the questions.
Yeah, this really enlightened us, and I hope it gave you some things to think about too by having folks with all different backgrounds and opinions asking you questions, and it's been really good to chat with you. So we appreciate it, and also say hi to Dory for us too. Yeah, where's my hand?
Will do. Appreciate the time and the questions, and have a good rest of your meeting. All right, take care.
Okay, thanks, Jeff. Bye-bye. Okay, yeah, so since we got into the topic of Evolve Houston, we can talk about that a little bit. Actually, Robert or Kevin, do you want to talk a little bit about Evolve Houston? Or I can.
Sorry, I was muted.
That's okay.
I don't really have anything new on Evolve. I did talk with them a little bit about metro buses, and it's going to be a long road with metro. They're just not. The leadership isn't there to really jump on the bus thing. And of course now the excuse is that with COVID, it's you know, bus ridership is not looking good, and so they're really worried about budgeting. And of course, to me, that you know, they have 1,200 buses. They replace about 100 buses a year. 100 buses a year they replace. And so the numbers are huge. And so, you know, really, they look in short, medium, and long term, and it's just not there yet. They're focused on their next product, which is a combination of a whole bunch of different things, everything from upgrading the bus stops and the sidewalks. They have a big sidewalk thing, to adding more rail. But as far as Evolve, I don't have anything specific about Evolve going on. This, you know, the pandemic has really shut down a lot of meetings and things. I don't know if either one of you have something more to share with us about Evolve.
Some of us, just to let everyone know, had a discussion with Kate, and she was going to be moving from Canada down here to Houston. I've forgotten the time frame of when she was going to be moving. Either of you guys remember? It's not that important.
It's going to be the end of this month, I believe, and
okay.
I believe July into August.
Yeah, because I was just kind of thinking that, I mean, just natural human nature, when you're farther away, you're less able to get involved. And so whenever that move happens, I'm just thinking that in spite of the pandemic, you're still picking up the phone, you're in the same time zone and that kind of thing. That maybe she'll be able to get more done. So I don't know if she's in a volunteer position or a paid position, but she sounded really excited when we were all talking to her, and that's great. Because we all know that the opportunities on the bus side, on the car side, and yeah, I brought up people in the oil and gas industry because I think there might be initial hesitation there. You know, people have been working oil and gas. I have a neighbor across the street, his whole career he's worked oil and gas. That, you know, those are folks that, sure, they see electric vehicles, they say, yeah, we know they have great acceleration, but, you know, I've owned a gas car all my life for many, many decades, and that's all they're interested in. And so I think that's a segment that we need to educate as well, but in a more specialized way than other folks that may just, you know, work in a department store or something like that. That in terms of changes in their industry that are happening, and how electric vehicles are very desirable for lots of different reasons. But yeah, I'm thinking that Kate coming down here might energize some things that you know, tend some of the discussions over to the oil and gas folks. Because I'm sure, I mean, you talk about the 100 buses a year. I'm sure the oil and gas people haven't been you know, ignoring that they could lose, you know, year by year, you know, buses in this city that obviously use their product as fuel. So that, yeah, it'll be interesting how the Evolve Houston tackles a lot of different things. I thought it was really positive that they had the table there at the Houston Auto Show way back when, and so that they're interested in communicating with a lot of folks. Of course, some of the other developments here in Texas, a lot of folks have probably heard the discussions about Tesla building a factory outside of Austin. And I even looked on a map, and it's like, wow, yeah, that's a prime piece of real estate right outside of the new Austin airport. And of course, they would then tap the Austin area for both plant workers and for educated engineers and management folks and things like that. So I think it would be really interesting, especially if they go beyond what they call a gigafactory and make a terafactory. We all know that lots and lots of batteries are going to be required for all these EVs that are coming, whether they're coming from VW or from Korea or from Tesla. But yeah, when I started off with beginning of this session about all these different car companies, So Workhorse has gotten more recognition. The Lordstown Motors has gotten more recognition. One of the articles talked about how the post office is going to be replacing a whole lot of their old vehicles, ones that most people think that's the only thing the post office has ever driven, because they've driven those same vehicles for so many decades. But I know there was a bill proposed in the US House. I don't know if it went anywhere or if it will, but it was going to actually require, when the post office replaces vehicles, that a very large percentage of them be electric vehicles. So we'll see whether that and of course a lot of other proposed things going through the US House. Yeah, so other things in the news folks want to talk about, or projects.
Yeah, I was kind of disappointed. All this talk about new variations of vehicles kind of made me kind of sad that Tesla's battery day was postponed off into September, I guess. So they make it a bigger and badder presentation, I guess.
Yeah, I know it's been postponed a couple of times. The last thing I read was that it was going to be part of July 22nd or something like that, when they have the regular, after the end of the quarter results.
Yeah, that's not really what they say now. They say September time frame is what Elon is saying now, because they want to actually have it at their secret battery development plant just south of the first gigafactory there. And so that's, I guess they're just wanting to be able to actually host people in person to make a better event out of it. Sure. So they decided to push it way off and into September, I think.
Yeah, I heard that the Apple Mac big event that they've been holding every year for a long time really was quite strange. They did it in the Steve Jobs Theater, but there was no audience there. Everything was done remotely.
Yeah. I watched a bunch of it. It was very well produced, and a bunch of it was pre-recorded. But it started in the Steve Jobs Theater, then it went up to the atrium, and then went over to another gym area. And it just zipped around to the various places of Apple campus and, for all these highly polished and produced presentations. But yeah, there was nobody applauding or hooting and hollering or anything. So they just went about it. But yeah, they announced the end of the Intel Macintosh, which I thought was interesting. But
right, so they're going to their own chips, just like Tesla went away from NVIDIA chips. Yeah.
No, actually, they're going to be ARM chips, ARM-based chips, and they're going to do their own graphics processors and not be dependent on NVIDIA or anybody, actually.
Yeah, so, their own design, right?
Yeah.
No, I was just doing a comparison. Tesla went away. They had previously used NVIDIA products, and then they decided to bring things
exactly what I mean. If you can justify it, then if you have the talent pool, then why not make custom silicon for you? Because that's what's in my car now. It's one of the reasons I got it, is it had the dual Tesla chips inside of there that just blows away anything any other competitor could put in their cars. So, and someday we'll have self-driving, I guess.
Right. Yeah. It's interesting to hear these little comments from GM and other companies, and of course from Tesla. So Google. We'll see what speed the types of things that people are expecting come out. But yeah. But we were talking a bit about the European car makers jumping onto EVs. It really sounds like some of them are really starting to take the laws that have been passed in Europe seriously. And of course, they look at the car market as a worldwide car market, China, US, Europe, so on. And so I think that'll be interesting to watch the upcoming competition between world car makers. Projects. We don't have Robert Powell here today. He's always good to talk to about his motorcycle projects. But Mike Zutek, have you got more developments in your projects about putting things onto your camper? You're muted, I think, Mike.
Mike needs a mic.
Yeah.
There we go.
Yeah.
How's that? Can you hear me?
Yep, we can hear you now.
Yeah, well, good news, bad news. The good news is that the little companies that that I'm the president of have taken on some very fast-paced, good new work.
Good.
So that's great for the little companies, but it has been bad for all of my projects. They probably won't get a whole lot of attention until about 2 months from now.
Yeah, well, you know how it goes.
Yep. Yeah. Well, you know, you have time or you have money. It's hard to have both at once. But this will put me in a position to mess around with other upcoming EVs. Should that look like it's interesting? And I have to say, the 200 kilowatt hour in the Cybertruck, weird as it looks, would be very exciting for pulling a camper. Right? You can go further, and you stay at the very top levels of charge longer. Right? The capacity of your battery determines how soon the current limiting starts to kick in. Mm-hmm. And that vehicle would slurp the heavy juice for considerably longer. So effectively, a stop, you can add more miles. Simply by having the big battery that can suck up the power faster. Anyway, yeah, I'll have some money to play with and we'll see where it goes.
Well, good. It sounds like the tasks that your two small companies picked up are really exciting.
Oh boy, yeah. It's legal support work, which is not only exciting, it's challenging, it's difficult. It's not the most fun thing that we do, and it's not the only thing we're doing. We're also doing some wind turbine blade design, which we really enjoy. So, variety of projects, good stuff. Thanks for asking.
Yeah. Well, thinking of blade design and other component design for wind turbines, I read that in New Jersey, the state government is looking at making New Jersey on a particular piece of land right there along the shore, I guess along the Delaware River, a hub for all the wind turbines they hope to put off the coast of Virginia and off of New York and off of New Jersey. And so they're really paying attention to that. And so there should be more electricity supply. Of course, that's always good for EVs, right?
Yeah, well, you're pretty well up on things. In fact, the amount of resource off the East Coast is absolutely enormous. The wind blows both stronger and more steadily offshore than it does on land. And their power prices in that grid area are very high compared, for instance, to Texas. Texas is a lot more difficult to penetrate with more wind in terms of being able to support the economics of it. But boy, out on the East Coast, they have the ability to move that forward very quickly. So it'll be interesting to see how fast that goes forward. But yeah, they're positioning themselves in a very interesting way.
Mm-hmm. Yeah, that sounds like an industry of the future, if you ask me. I mean, from what I read.
Yep.
So thinking of electricity prices, Fred, glad to see that you're here with us. And of course, when I see you, I think of things like electricity prices.
Yeah, that's pretty much all I do all day, every day. But yeah.
Really, all day, every day.
Yeah, I'm actually trying to put out a better tool. I did put out a calculator in case others aren't aware that particularly for solar owners and EV owners, if you're not sure if you're on the right plan, you can download your Smart Meter Texas data file and dump it into this Excel calculator, and it'll crunch the math for you to tell you if you're on the right plan or not. And then and I also maintain a list of all the buyback plans and other kind of time of use plans that are most pertinent to EV owners. I'm in the process of updating and formalizing that list on its own page as well. So when I get that out, I'll send a link out to folks.
Yeah, that would be really appreciated. There's folks, so Emma's on the call here. Of course, she's got PV, and so she does net metering for hers to feed her car and her house, and a number of other folks here do too. So I think a lot of folks are interested if there's new entrants in the market that are, maybe offering something better than some of the older competitors.
Yeah. There's the established folks. A lot of people get complacent in their plan, but depending on the size of your PV system, a 1-to-1 net metering plan isn't necessarily the cheapest option for you. If you have a small system relative to if your import to output or to export ratio, no, if your export to import ratio, sorry, is below like 40%, then you're actually usually better off on a non-1-to-1 plan. So whether it's just a straight power to choose plan or a gritty or evolve or something like that. So the math is tedious, but it's interesting when you start digging into. And then I'm curious, and it's on my to-do list to try to figure out if I can put in predictions for batteries as well. So not just what ifs about certain solar system sizes, but also batteries and the possibility for arbitrage with the nighttime and daytime rates. I think that would be interesting to be able to look at those models as well. So when I get that up, I'll certainly let everybody know that that's available too.
Yeah, reach out. You can put things directly in the forum on our site, or you can send things to me or to somebody else, and we can put things on the site as well.
Sure.
And I'm usually thinking the site, but we also, of course, have Facebook.
Right.
And I was really impressed last time we had a solar tour here in Houston back in October, I guess it was, that 2 out of the 3 houses in my local part of Houston had batteries in their recently installed solar system. So that was new. I mean, I've been going to solar tour houses for years and years, but to have 2 out of 3 with batteries, I thought was impressive.
Yeah. That's why Jeff's presentation was pretty impressive. I'm curious how many other companies may be looking to do the similar kind of thing, because it's basically just having a capacitor at the edge, right? So you don't have to have an overbuilt delivery system if you don't need to, because the average is 50%. Why do you need to build the sizing for 100% if you can just put a cap out there, so, or a battery? So curious to see how that works, and what other industries it might expand to, or applications.
Right.
Yeah, I'm curious, Fred, back on, I don't have a PV system at all, but I certainly have a charger demand, and I've over the last few years elected the green option from Tri-Eagle.
Oh yeah, okay.
Because it it's just basically pure power credits from the wind turbines out West Texas. Do they have any other good competitors? Are there any other options for that renewable energy dedication?
Oh yeah, well, actually, one of my my hot button topics is so-called green energy plans, right? And the effectiveness of them. So there are dozens of retailers that offer green plans that are just backed by voluntary RECs from Texas Wind, which is an abundant supply, so much so that they don't cost anything. And also they don't do anything either. So they don't incentivize any more growth with the generators. They're immaterial to their decisions to make the next wind farm or solar farm. So I consider all those plans to basically be greenwashing, and I've never found one yet that defensively makes a difference as far as additionality goes. Now, if you want to make a difference, I think some of the best options right now are probably gritty. If you happen to be if you have a smaller solar system, not only can gritty make sense financially, but it also definitely motivates you to change your behavior to use power when it's cheap, which correlates with when it's coming from wind and solar, and that arguably has a net positive effect on reducing fossil fuel emissions and whatnot. And there's maybe one newer retailer that they only sell plans that are based on cheap wind RECs as well, but they or solar RECs actually, but at least they're part of a large solar conglomerate. It's Chariot Energy is the retail subdivision of 174 Power Global, who makes utility solar farms around the country, and they're a subsidiary of Hanwha, which is a South Korean mega company that makes solar cells, but they're also an oil and gas company. So that's a little dicey as to whether they're truly a green play or not. So yeah, going back to your question, I don't think there's anything particularly special or unique about Tri-Eagle. And so yeah, there's probably other options that would be cheaper, certainly, and there may be one or two that would be more meaningful from a green perspective, but it's hard to directly defend any of them.
Yeah, watching out for that greenwashing is something always to.
Yeah, and I've dug like we're aware of all the companies that sponsor Earth Day here in Houston every year, and but those same companies, they charge 12 cents per kilowatt hour, which is probably a 50% premium over the market rate. So are they getting that premium because people perceive them to be better and greener? Is it just really a marketing play that they're claiming these differences? But at the same time, when you go look on their site, try to figure out where that premium is going. All the sites that they name are all 10 or 15-year-old wind farms that have long since been financed, and once you build a wind farm, then the game is over. Basically, there's no fuel cost, so it cranks out power for free. The trick is getting the financing to build the thing in the first place, and nothing on their list was newer than 10 years. The last time I looked, out of like 60 wind farms, and so yeah, I'm just really skeptical of the whole system. So, and there's a lot of researchers that agree that voluntary recs don't really move the needle on anything. In other states where they have a stronger renewable portfolio standard, then mandatory recs do make a difference. But Texas has unfortunately outgrown the merits of the system, and there's just a hopeless amount of slack in the chain, so it's never going to really make a difference. You'd be better off just sending your premiums directly to, or saving them up for a solar panel, or pooling them for some nonprofit to build their solar panels or something like that.
Yeah, I was thinking, donations and such.
Yeah, that's really the best you can do.
Thinking of new wind in Texas, maybe how are the power lines? I'd heard some of them had gotten saturated, all the CREZ lines went in and so forth. But in terms of new wind going in, are they able to connect it? Is there much new wind going in?
I'm not really familiar with that. I don't know. But,
okay.
I guess it comes down to that steady state versus peak load that that Jeff and them are trying to all address with local storage and whatnot. So we'll see.
Right. Well, I think the whole idea of peak load is kind of changing from what it's been for a long time. I've heard in Arizona that during the daytime, there's areas with so much solar that peak load is not the traditional middle of the day.
Right. Yeah.
But there's so much power available. The traditional guys don't want to turn off, and of course the sun is shining so many days out of the year in Arizona that that's not a peak because there's so much supply. It's not peak pricing. I mean, the numbers of kilowatt hours flowing, per hour or per whatever unit you want may be high, but it's not peak pricing because there's so much supply during that time.
Right.
So.
And that's good, right? Because all you got to do is figure out storage then, or make hydrogen, or you can always do something with too much electricity.
Right. You can have that peak in pricing occurring, right at sunset type of thing, where there's still quite a bit of demand, but your supply has gone way down.
Right. Yep. Exactly.
Yeah. So I was going to ask Sigrid some more questions here, but I guess she just dropped off, so we've lost her. But Bill, I wanted to ask you something, Bill Swan, if possible. What have you heard, if anything, from Roland or about the move of the TXRX to its new location? I know a location had been determined and given out, but of course, the world's changed.
No, in answer to your question, the labs have closed about a week ago, and so I haven't been down there. And I'll make a point of asking if you'd like.
Yeah, if you could, because we'd certainly, if they're willing to let us use space for free, you know, in their new building, we'd certainly want to take them up on that offer.
Sure.
Yeah, you know, thinking that they're going to want to have a classroom or more in their new building.
Yeah. Hey, Robert posed a question. I repaired an electric bicycle for him, and he's offering it. He says free, but let me see. My phone just rang. He says free, but I think a small contribution to the club would be appropriate. And I've got a picture of it here. I'm going to try to share it. It's a mongoose with lead acid batteries, and I don't know whether this is going to come over. Well, how about that? It doesn't come over.
Yeah, your green screen. Oh, at an angle there, it came for a second.
Oh, that's interesting.
Yeah, your green screen activities wants to.
Never tried this.
Well, you hit it again there for a second.
I know. I'm moving my phone, and if anybody, Kevin Douglas wrote it the other day. I've ridden it. I haven't tested the range. I replaced two 12 amp hour lead acid batteries with 7 amp hour, just because I had them. And again, it's offered for a small donation to HEAA. That's what I would pose. And I guess if you're interested, I mean, it goes plenty fast. I don't know what the range is, and take it up with Dave, I guess, in terms, or for that matter, Robert. There you go.
Yes, yeah, folks can always contact me for anything. So yeah, that's good. All right, thanks. Yeah, I hadn't gotten to that yet, but I saw it at the bottom of the chat there. So that was something we want to let folks know about the availability of. So good. So thinking of things happening in industry and such, I see that Chris Hayden is on. We haven't heard from you, Chris. I don't know if you're close to your mute, unmute button, if there's anything that you can share with the group or not. I mean, generally, of course, we hear around the country how solar is getting installed on more and more places. And of course, the old saying is, which comes first, the EV or the PV? So many folks get both in the end. So Chris may be away from his unmute button there, but and Emma, I wanted to ask how things were going in your part of the world. If you're close to your unmute button.
Hi, everyone. Yeah, I'm doing fine. Been picking Bill Thompson, or
Jim Thompson.
Jim Thompson, sorry. Jim Thompson's brain about battery storage.
Good.
I signed up for the East Houston Sun Co-op. So encouraging anybody else, we need 2 more people before they can get the, put out the RFP. But
good. Yeah, good to know. I know they were working on it. In fact, I should have asked Jeff. His wife Dory had given him the latest number, but you just did. Good. So
yeah, I just looked it up because I think two other people joined recently because I was trying to push it amongst my other friends and folks in the area. So yeah, so looking forward to hopefully having some backup battery for the hurricane seasons in the future. But also to take advantage of the 26% federal tax credit before.
Right, that's something that's good. I see Fred shaking his head there. Yeah, folks that are considering solar should be aware that it's going to drop from 26% as of December 31st. So, and obviously the folks that do installations will get busy right toward the end of the year. So you got to plan ahead. Very good, very good. So when you're talking about batteries, and I thought maybe next you were going to say you were going to make it portable so you could put it on your camping trailer and have power when you pull your camping trailer.
No, that would be nice, but maybe I'll have to find some solar panels that are portable.
Right.
Actually, I actually just purchased what is it called? an electric cooler for, yeah, for taking on camping trips.
Sure. Oh yeah, that's really practical. Yeah, in fact, was it from Mike Zutek or somebody that was talking about how, or maybe you and I were talking, Mike, how the refrigerators in campers were now starting to go away from them being also propane fueled, that folks were just running electrically all the time. So whether they're traveling or at a campsite or whatever, that's the trend, is to just make them a lot simpler. You don't have to worry about the whole propane supply and, having a system to create cold out of burning propane and so forth. But
Yeah, that's what I went and retrofit onto my camper. And of course, when you've got the solar panel on it, even while you're going down the highway, you're going to be producing, in most days, considerably more power than your little highly efficient refrigerator actually uses.
yeah.
So I decided that it just made a ton of sense. The symbolism of being even further removed from fossil fuels, silly as it is, it was also part of the decision. I like to do that. And we actually now have 2 of the little electrically operated coolers. And partly this is part of our whole hurricane escape thing, that the low power input, you can keep one of them for frozen foods, and the other one can be for foods that aren't, they're chilled, but they're basically like in the refrigerator part of your refrigerator as opposed to the freezer. So we've got 2 of them now, and of course we've got 2 EVs, so it's nice to have one in one and one in the other as another addition to our hurricane plans. And a lot of things were in process in terms of further enhancements until I got busy. But the equipment is here at least. The full integration is not, to give you one more item there, I've got little generators, rather than spend $12,000 or something like that on a full home system. Got a couple of little Yamahas. You can pick them up, carry them around. They're less than 50 pounds. And you're only going to use them if you absolutely have to, right? They'll run off natural gas, they'll run off the propane, or they'll run off gasoline. So I like to tell people we've actually got more ways of keeping our vehicles moving than anybody else, because if there does happen to be electrical power, you can just charge from that. But if you don't happen to have it, you can charge from basically whatever the heck you can get your hands on. So it's truly a high versatility thing that I hope to never use, but it's there for hurricane escape requirements.
Right. Yeah. Well, versatility it costs some money, but usually worth some. Bill, you want to say something?
Number one, I'd like to ask what the voltage and source for these small refrigerators are if they run off of DC. Also, Emma mentioned low-cost solar panels. There's a company in Houston called Salvex.com that's offering used panels taken from a solar farm in Central America at 10 cents a watt, even though I've gotten them for 8 cents a watt. They're not, they're good. I mean, some of them are damaged. The electrical cords are damaged. You can replace the MC4 connector on the end of it. 4,000 of them. There's lots of them.
Salvex.
And they're local.
Yeah, that can make a difference, because shipping, of course, can ruin a good deal. Yeah.
So to answer your question, they operate on 120 volt AC and 12 volt DC. And the 12 volt DC, the nice thing is that's the native. So you're not gonna, when you're running from your battery, you're not gonna be paying a conversion inefficiency. The conversion inefficiency is on the AC side.
Okay.
And the source?
What's that?
Where can you examine and purchase one?
Oh, I just got them off the web. I think the name of the unit was Osranvik. I'd have to look it up. It's kind of a weird name. But one of the things I like, this particular unit has an eco mode where the peak draw is 27 watts. And it's not going to draw that all the time. It only draws that occasionally. But I mean, even in terms of peak load, it's like ridiculously low. It's less than 50 watts, even in the regular mode. So it allows, you know how the story is. It's just like with any kind of heating and cooling system. We've got mini splits here in the house. And the reason they're very efficient is that they're running almost all the time. So you're not pushing a tremendous amount of heat through a given radiator size in a short time, which is what a cycling system has to do. You're levelizing it so that the delta T in the radiators can be smaller and the system efficiency can be higher. I think this basically kind of does the same thing. It just uses the given size of its system at a low power level and has a higher efficiency in eco mode. So they're pretty attractive little units, and again, less than 50 pounds. This is something that easy to throw into the back of the Tesla is where it lives for me. We had one that would be there, and now we'll have one that can also go in the back of the Bolt.
So are these the solid state type of coolers, or are they ones with a working fluid?
Apparently it's working fluid. I've never actually tried to take a back panel off and see what's in there, but the literature that I read said it's a high efficiency working fluid.
Okay, good. All right. So anything else, Emma, that you want to bring up? If not, we'll ask other folks, because I see that Suresh is on and Randy's on. And so, Robert, we haven't actually heard from you. We've seen your words in the chat. Daniel Smith. Just want to give people an opportunity, because everybody's got different interests, and I try to hit a lot of different topics. There may be some things that you hear you couldn't care less about, but as long as it's interspersed with some other things that are of interest.
Yeah, I posted a link to what I thought was a very interesting article about grid scale energy storage through the use of cryogenic air.
Cryogenic air, okay,
Yeah,
so that's in the chat.
If you have excess energy, you want to, you can basically chill it and store it like large scale liquid natural gas tanks are stored, so that same infrastructure. And then when you need the energy back out, then you expand it and connect it to a gas turbine, very much like a natural gas plant would do, except it's very efficient long-term storage of that energy that went into compressing and chilling the transport gas, which is just regular air. And there's a big facility going in the UK that's supposed to be like a gigawatt size. So I thought that was pretty impressive. And it just leverages existing, mechanical technologies and thermodynamics technologies from the liquid natural gas world. I thought that was a little ironic, but we can leverage that to do grid scale storage and not need massive batteries or something. It could be a death knell for coal plants and natural gas plants.
Right, yeah. Yeah, there've been more and more articles about coal plants shutting down early, so forth.
Yeah, that's mostly just because natural gas has gotten so dirt cheap that they are actually building natural gas plants left and right and using those to shut down the coal plants.
Okay.
And, so it's a marginal win. I wouldn't call it a big win for the environment.
Right.
It's that shale oil and fracking gas and stuff that from Canada that's made it very cheap instead of importing oil and gas from abroad.
Yeah. Well, then with all that cheap gas and plentiful supply, I've also wondered, as they go through the process of liquefying it, how much more energy is wasted because it's not being used in just a compressed state, but rather an energy intensive liquefaction process so it can then be shipped around the world, but that's creating even more CO2 because they're using part of the gas to liquefy other gas to ship it out because they do have these huge supplies of it.
Well, yeah, that's right. I mean, it's a never-ending chasing your tail kind of thing with, you know, carbon fuel transport kind of thing.
Right. Yeah, and that's why kind of at the beginning I was talking about making hydrogen, and if you make it out of natural gas, of course you're still putting out a lot of CO2, but I just never before that one article heard it called gray hydrogen. So that you have gray hydrogen, green hydrogen, blue hydrogen.
Yeah, that's the little secret that I worry about is there's no such thing as clean petroleum products, and sooner or later there's going to be a big CO2 footprint somewhere.
Yeah, and what I'm kind of also afraid of is that somebody will sell a project and they'll say, oh, we're going to use green hydrogen for this, and then 3/4 of the way through they go, oh, well, we've got to switch to gray hydrogen because the numbers don't pencil out or something's happened or whatever, and then the whole green aspect of it goes away. And who knows, in reality they may have been expecting to do that anyways because they've got their buddies over in the traditional oil and gas business.
Yeah, back from my decades in the shuttle program, I have some misgivings about hydrogen in general, at least in its gaseous state. It's basically impossible to contain.
Yeah.
But
what do you think, because I haven't looked at it since I saw it in the article, that maybe for steel production and cement production and things like this that have traditionally used fossil fuels, would hydrogen, and especially if it could be green hydrogen, actually give you the high temperatures that you need to be able to produce those products?
Certainly, yeah. Hydrogen gas would burn very hot.
Mm-hmm.
So yes, your big factory, your heavy stuff still needs to heat it, but a lot of that's arc heating is what they do. So they're huge energy users up in Pittsburgh and elsewhere.
Okay.
When you're melting metals down in ore processing and everything, they used to use natural gas for that, but it's almost always arc processing now.
Oh, okay, interesting. Yeah. Okay.
So to follow up on a question that I left hanging.
Yeah.
Is that readable?
AUSRANVIK?
Yeah, this is the unit.
Okay.
And it says it has 1 ounce of refrigerant. I couldn't find anywhere in the manual where it identified what that refrigerant is, but it claims it's a high efficiency 12-volt DC native system, so that part was correct. Anyway, that unit, we can tell you, works. We put a lot of mileage on it, works fine from the cigarette lighter in the back of the Tesla. Well, I mean, 27 watts. I mean, right? Obviously, it's not going to challenge the system any. But we now own 2 of them. We like the first one well enough that we have 2 of them.
Okay, well, good. Yeah, I mean, as more folks get back to traveling again, they'll probably want to have coolers. And yeah, usually what we've always done is take blocks of ice that we've frozen at home because we just are trying to keep some drinks cool or something, not meats that are other things that are more sensitive to temperature and such. But that's good to know that you've had good success so much with one that you bought a second one.
Well, we started with the ice, and I can tell you if you're going to be gone for 2 months or so, you get tired of having the water get into the food bags, you get tired of having to dump it places, you get tired of having to go get ice all the time.
Right.
So we now have a little electric ice maker, which you may recall from when we were up there in Avanti. So we make our own ice from electricity, and we keep things cool from electricity. And that's about as far from fossil as we've been able to figure out how to get.
Yeah. Was that little ice maker 12 volt as well, or did you have to run it off an inverter?
No, that one runs on 120 volt AC, simply because it has a high power draw. When it's making its first set of cubes in 8 minutes, and it's putting out about 1 pound an hour. Wow. And you don't do that at a low power DC input. So that one is an AC unit.
Okay. Okay, very good, very good. And Jason, I wanted to mention to you that when I was reading an article somewhere, it mentioned a better route planner in it. It said it was a good thing to use.
Nice. It's always good to hear.
Just appearing in an article. So it's like, hey, I know who works on that.
Yeah.
Yeah.
That's pretty cool.
Yep.
Actually, I was going to mention something that I just stumbled across a month or two ago that I'm waiting on. I ordered one for the Bolt. There's a project called Open Pilot. I don't know if you guys have heard of it. It's autopilot, but open source for any car in theory.
Oh, okay.
It looks really cool. There's a project to get it working in the Bolt, so you know, it'd be pretty cool.
Good, good. Okay. And I'd like to thank Colin. He just sent me an email that he got our next month's event put onto the webpage. I haven't looked at Facebook, but so that, as I said, the link will change next month because we're changing hosts. So thanks, Colin, for putting that out there for everybody. And we'll be working on the recording. And one of the other things that gets produced is a text file of the chat. And last time I think we mostly had just questions in it, so I don't know that I really did anything with it. But this time, since we have these different links, Colin, we might want to think about whether we want to put this chat from the text file that gets generated by Zoom onto the site as well. You can think about that, whether it be worthwhile.
Yeah, the video has been up there for a month on Facebook and on the website. So for the June meeting, it's been out there.
Great.
Yeah, I didn't try to do the text file. Yeah, no reason why not.
Okay, well, as I said last time, I don't think that it really brought that much because it was just the questions that were asked. But this time with several different links in it, it's always, of course, more convenient than having to ask somebody by email or whatever. So, Randy, good to see you there. You look like you're outside in the daylight. My background is turned all dark because it's nighttime here.
Yeah, it is nice out here. I've been installing electric fans under the porch while we've been having the meeting, so I've been doing my part.
Well, good. No, that's good use of time. Absolutely, yeah. As I said, try to hit on all different topics, and some folks may not find interesting, but hopefully everybody finds something interesting. So, yeah, having a good fan to be able to sit outside, that makes it enjoyable, both for the temperature and maybe also keeping bugs away. I'm always a mosquito magnet. My wife always jokes that she doesn't need to do anything because if I'm standing close by, the mosquitoes always come to me.
You're number one target.
Yeah. So, and
Yeah.
Supposedly it's the CO2 is what attracts them.
This is Emma. Can you guys hear me? I forgot to mention one thing. And I have a neighbor who's actually a chemist, and I forget the name of the company he works for. But I was chatting with him, and I think it would be interesting to have him as a speaker in an upcoming meeting because he's working on different battery chemistry. So.
Oh yeah, that would be good. Robert's tentatively got a couple of people for the next couple of months, but we've done meetings, as you know, in the past where we've had a couple of speakers. So that works out too, or depending on availability of these different folks where they would flow. So yeah, if you can send something in email to both me and Robert, that'd be great.
Okay, sounds good.
Appreciate it. Yeah. Okay. Robin, I see that nice red car behind you again there. Yeah. Good. Yeah, it's always nice. I understand everybody can't always have the video on, but it's always real nice. I appreciate it, Randy, that you got the video on. Yeah, doesn't always work.
I was having video camera problems earlier, so I had to turn it off. It froze up on me a little bit. So I figured it's safe here at the tail end of things to try it on again.
Yeah. It I think helps, and with speakers speaking, I think that, you know, even if they're not going to hear a lot of people wanting to interrupt because they're just wanting to be polite, just seeing the folks and stuff, I think is good. I was on a webinar by Plug-in America a week or so ago, and they were using the webinar mode. They said they had 500 people online, and actually, I guess the way Zoom works with webinar mode is you don't see everyone participating like we do here in a meeting. They had the 4 or 5 people, I guess they're mostly out in California, who were running the meeting. Each one had a different part of the webinar that they were covering. But they mentioned that there were 500 people logged on. So the whole time you would see those people and it would jump from one speaker to another. You wouldn't see all the other people participating. But the way we do these meetings, of course, everyone who's participating is available to be seen on screen if they've enabled their video. And it just, I think, adds a lot more since we're needing to do these virtually. Actually, one thing I was talking to Colin and others about is we'll plan on meetings, so August, September, October, November, because things aren't moving fast. And we'll see if in December we can actually have an in-person social or not. Sometimes people are saying that we won't be able to do much until we actually get a vaccine out and then available for people to actually get shots. But we'll just play that by ear. There's obviously plenty of time between now and December. But it does kind of beg the question, because we've had this nice tradition of all getting together for a December social, and this year maybe we will, maybe we won't. We'll see. But it seems like these virtual meetings are working pretty well. We've got people asking questions, and that's real good. And as I mentioned, next month we'll have Vivas Kumar back again. And if you remember, he worked for Tesla and he worked with the minerals for batteries for them. And he's now, I don't have it right in front of me, working for another company as well as doing graduate work out at Stanford. So he's really digging into things, but he's giving us a little bit of his time. So we really appreciate that. So we'll have him next month.
What day is it next month, Dave?
That is on August 6th. So just a little bit more than a month. You know how the first Thursday always kind of moves around.
I may have to miss it. I'm getting married on August 1st, and I should be on the honeymoon at that time. So,
well, congratulations.
Well, you've got a good excuse for Pete.
I have a good excuse, although I still
Congratulations.
could. Thank you. Thank you.
Yeah. Fantastic.
Still gonna be interested in what he had to say.
Yeah. Yeah, Emma found the clapping hands. Yeah, it's probably down here somewhere at the bottom.
Yes, Emma, thank you.
Yeah,
Thank you.
reactions. There it is. Yeah, I can do that too. Okay. Yeah. All right.
Just got the marriage license today. Harris County has shut down its clerk's office, so there was no way to do it that way. So we found out that Galveston County works just as well. And so we went down to League City and got the marriage license there instead. And it's a Texas thing from a legal standpoint, so it really doesn't matter. We found out where you get the marriage license.
Okay.
That's good.
Do they do blood tests and stuff anymore? I don't even know.
No, they don't do that anymore.
Okay.
They ask you all kinds of questions about, related to inbreeding and stuff. And we're not related in any way that I know of.
Yeah. Okay. Interesting. All right. Yeah, I was just trying to think of other things that would be stumbling blocks with the, COVID and distancing and things like that. But,
yeah, we were surprised they were open. They were taking all kinds of precautions down there at the clerk's office.
Yeah, because even before the COVID came around, I'd switched from going and getting my annual car stickers at the annex of the county office to doing it online. And so now it's the same doing it online, but you do need to still take your EV over for its $7 inspection. So our inspection guys are real good at keeping their distance and everything. So I've gone to the same place for a long time. Other places earlier I had gone to before I started going to this one place, and even maybe the very first time I went to this one place, they actually wanted to get in the car and test the brakes and lights and blinkers themselves. And now they just walk around the back and they say, do left blinker, right blinker, honk the horn. So they just let me do it all as opposed to them needing to get in the car and breathing in it and everything. So it's really pretty distant, but you still get the essentials done for $7. And of course, they put it in the computer system and go online at home and actually have the sticker mailed to you.
We just took a trip down to Corpus. Andrew drove his Bolt down there, took us, and Corpus is not very much, Corpus Christi is not a very friendly EV place. There are hardly any charging, fast charging stations. We ended up taking our juice box and hooking it up to my daughter's dryer 240 outlet, which worked just fine for us.
Good.
Yeah, I'm glad we got that kind of device here. So anyway, it's just really amazing how, just unfriendly some cities are towards that and what they offer or don't offer.
Yeah. Well, good that the arrangement at your daughter's was good between the driveway and where the dryer was, and the connection and so forth. Yeah. It could theoretically be really far apart and make it difficult to do that. So that was good that worked out. But,
Hey, Randy, so Andrew found a bolt, huh?
He did. He found a bolt. Interesting. He just fully charged it on the trip there, and we had a 50-mile buffer, which was fine. Ended up with 25 miles once we got there. When we charged it, we were at 81, 82% to come back. Only 5 miles buffer. Ended up with 40 miles over when we got back. So he just did a really good job what he was doing, and you just and didn't do 75, did 73, but not 75.
Good.
Did the route planner.
Maybe more downhill also.
Yeah. Well, what's kind of funny, and this is really a good thing. My son-in-law is really helping to build the Exxon. There's an Exxon plant going on down in Corpus. And so it was a really good education for him, for us to do this and to, really talk about that and really expose them to this. That was the fun part of it. It really was. Asked a lot of questions and everything else. And he helped out. He, put together a NEMA extension cord for us to be able to plug into the 240. So that really worked out great. And so, very accommodating, but it's that kind of education process that, it takes, one at a time.
Yeah. Did he get a chance to drive it and feel the acceleration?
No, not yet. Not this trip. We will do it another trip.
Okay. Sounds good.
Yep. We had more of a birthday celebration going on, so we just didn't have time for it all.
Sure. No need. Absolutely. But
oh yeah.
There's that old expression, butts and seats. That's what really convinces people that.
Oh yeah.
These are good cars. Yeah. So yeah, well, that's good. Yeah, getting people exposed, that's what it takes, and a lot of times it's just one person at a time to expose them. Yeah, get them to know. So yeah, that was kind of the emphasis that I've been talking with some of these Plug-in America folks. That's kind of what they're emphasizing, because that's their purpose in life, is to get people around to know what's happening. And as I mentioned, Kate from Evolve Houston is going to be setting up Ride and Drive here in Houston. I think it's later this month of July that they want to do it. They're calling it a pilot, so they just want to do it kind of small scale. But you'll all be seeing an email that we'll be sending out that will describe, and it also will have a survey. They'd like to know some things from folks via survey. And so we'll send that out to the big group when it's ready. All right. Anything else? Some folks have stayed quiet, but that's okay. And but there is an opportunity now before we wrap up. If anybody else has questions or wants to emphasize something.
Dave, I sent a question in the chat room about evangelizing. If anybody has any ideas. I know we discussed it in length last year, and then I think most of that trying to take out, we don't have the budget to take out ads, and it's not always the most effective way, on dead paper, newspapers and so forth. So just any ideas, just how to get the word out just from among ourselves, and unless we want to just pass along the hat to get an advertising budget or something.
Yeah, we can discuss those kinds of things. And actually, thinking of things I wanted to ask you, Robert, is have you been traveling back and forth to work or working remotely, or how's that been working for you?
No, my job's been a victim of the COVID, so it's like people are driving less and flying less, and so using less petrochemicals. So, yeah.
But you were involved with a project doing some construction, weren't you?
Yeah, I was in Port Arthur. It's Total Petroleum for petrochemicals, ethylene project.
Yeah. And so that got to a point where they said they didn't need you.
Yeah, it's a very volatile industry, and then you had a price war between Saudi Arabia and Russia, and so
Yeah.
very volatile industry. So
Okay. So you're at your house in Houston then, I guess.
that's correct.
Okay.
So
All righty then. Okay. Well, thanks everybody. We'll wrap it up, and so you can see things on the website, and we'll see you a month from now. Okay. Thanks. Bye.
Thanks, Dave. Have a good night.
Thanks. You too.
Dave, where's that website again?
The HEAA.org.
Ah, too easy. I couldn't.
Right. No.
It's something that easy.
No, I actually should have said the letters. Yeah. That's
No problem.
Yep. HEAA.org. So, yeah. All right. Take care, everybody.